Well, we just took our, in Notability, we just took our test over the rationals and rational functions. And so I'm going to start a new note sheet, and you guys probably should do the same thing. And I'm going to go back and I'm going to name that logs, LOGS. So again, that is short for logarithmic functions. And logarithmic functions have a very close relation to exponential functions. So we've done a little bit of exponential stuff. We have not done anything with logs so far. So this is going to be totally new for you guys. So please, at any time, please make sure that you guys just ask questions as we move right along. So let me explain why we have logarithmic functions, and then as we move along, I think hopefully that's going to make sense where we can apply that. So first, going way back when you guys first started learning about this math stuff and you first learned addition, after you learned addition, you then soon learned subtraction because you needed something to undo the addition, okay? So those inverse operations, you learned then multiplication, and then soon after learned division, because those are inverse operations. Okay, so multiplying by 5 and then dividing by 5, those two operations cancel each other out, and you get back to where you started from. So an exponential function is something that has an variable as its exponent. So I'm going to erase this in just a minute, but just so you know, if I had like y equals 2 to the x, okay, that's an exponential function. It's exponential because the variable is an exponent. And so like, how do you undo something to the x power? Well, the way to undo that, its inverse operation, is called a logarithmic function or a log function. So the inverse of that would actually be y equals log base 2 of x. And that's how we would write it and how we would speak it. We say it's, when it's written, this stuff is all written the same size and on one line. This too is a subscript, so it's written smaller and it's below the other line, okay? And we would say log base 2 of x is how we would speak that. But anyways, these two things are inverses of each other, okay? So if you take 2 to the x and then log base 2 of x, those two operations undo each other. That's kind of why we have logs, because we need an inverse operation for exponential functions. So let me get rid of that and then first start in by talking about some inverse functions, okay? So for example, we are going to find the inverse. And this you probably should write down. I'm not going to erase this. So let's say our first example, we have a function f of x is 5x to the 1/4 power. So that's our function, 5x to the 1/4. We want to find its inverse. Well, the way that's denoted is we would do f and then this little -1 right here. This means the inverse of f. So we want to find the inverse of f. Okay, so we're given the function 5x to the 1/4, and we want to find its inverse. All right, an inverse undoes the original function. So try and give you guys a little bit of a picture idea. So you may recall our function boxes, right? We drop stuff into the function, and inside here it does a bunch of stuff and it kicks stuff out. Remember, the input goes into the function, okay? That's like our domain. The output comes out of the function, that is our range. So in this case, if our function is 5x to the 1/4 and I put something into that function, well, the first thing we're going to do is we're going to take to the 1/4 power. Okay, so like if I say, hey guys, find f of 10, okay, that means you're plugging 10 in for x. You'd first do 10 to the 1/4 because you're orders of operations. So you take to the 1/4 power, and then you multiply by 5. Okay, so if I asked you to plug 10 into the function, you'd take it to the 1/4 power, you'd multiply it by 5, and it would spit out some answer. Okay, I don't know what it is. I don't care what it is. I'm not even going to find it. What I want to find is something to undo that process. So what I need is I need another function right below here that is going to undo this stuff. Okay, and in fact, it's going to undo it in the reverse order. So if I took 10, dropped it in, and I take it to a power of 1/4 and then multiply by 5, I have to do those things in reverse order. So I'm going to divide by 5. Because this is the inverse of that. And then I'm going to take to the 4th power. Because that is the inverse of that. So I need to come up with a function that we're going to divide by 4. I'm sorry, divide by 5, and then take to the 4th power. Well, let's just think that through. You're taking your function, your inverse function. When you take your number, you're going to divide by 4. I keep saying 4, I'm sorry. Divide by 5, and then take that whole thing to the 4th power. That is its inverse. So this is our answer. Okay, now order of operations are really important. We have to divide by 5 first because we have to undo this first. And then we take the whole thing to the 4th power because we have to undo this part. Or some students also like to look at it a little bit differently. I'm trying to give you a multitude of ways to look at it. I'll just set that aside. They'll say, all right, instead of taking a number, dropping it in here, doing this, and then doing this, and then spitting a number out, we're going to go the other way. So if we take a number, we have to undo this and then undo this to get back to where we started. So that's kind of another visual for you. So if we start down here and we have to undo multiply by 5, we're going to divide by 5 and then undo this, take it to the 4th power, and that's going to get us right back to where we started. That's what an inverse function does. Okay. So however, helps you guys think of how to do that. This is our answer. There is one last way that I also can show you guys, and that's a little bit more algebraic. And you don't have to do all 3 of these ways. I'm just giving you different ways that need to help you think about it. A last way would be write this as y equals 5x to the 1/4. Okay. So I just rewrote that and then switched the x's and y's. X equals 5y to the 1/4. So you switch the x's and y's and then solve for y. So if I solve this for y, okay, first thing I do is divide by 5 on both sides, right? So I get x over 5 equals y to the 1/4. And then to get rid of that, I have to take both sides to the 4th power. And those cancel. And I get y equals the quantity x over 5 to the 4th power, which of course is our answer. So that would be a third way that you could think about doing it. So I gave you a lot of different ways to think that through. Let's try another one, okay? And I'll go through them, and you guys can ask questions if I'm going too quickly, but I am going to speed it up a little bit. Let's say that f of
Can you
x.
show the third way?
Yep. This way, I think you're asking about, right? Yeah. So in that case, you take your original problem, okay? And some students love this because it's definitely more systematic. Like it's a, it's a system that works. You take your original problem and just write this as like y equals. So you write as y equals, and then you switch your x and y. So now it's x equals 5y to the 1/4 power. And then I have to solve it for y. I got to get that by itself. So the first thing I do is divide that over to the other side. And then I have to get rid of that y to the 1/4. So I take both sides to the 4th power because those two things make that just y equals. And I get y equals x over 5 to the 4th power. So I'll show you that process again in our next one. Okay, and that works all the time. So for our next one, let's say our function, and this time is the square root of x plus 10. Okay, and we want to find its inverse, f inverse of x. All right. So because I just did this green method here, I'll do that one first, okay? But we get the same answer no matter what. So I'm going to write this as y equals the square root of x plus 10. Then I'm going to switch the x and y. So I just switched those. So x equals the square root of y plus 10. And now I need to solve that for y. So first thing I got to do is subtract that to the other side. So I get x minus 10 is equal to the square root of y. And now to get rid of the square root, I square both sides. So y equals, and don't forget, put that x minus 10 in parentheses. So I squared both sides. And that is our inverse, the quantity x minus 10 squared. That's our answer. So again, some students like this method because it is methodical, but some prefer to think it through the other way. You know, if we had our function and we plug a number into there, well, the first thing we do is take the square root, right? So the first thing we would do is square root, and then we would add 10. So how do we undo that? Well, to undo that, if we want to go this way, we would subtract 10 and then square it. And that's what we're doing in our inverse. Subtract 10 first and then square it. All right, any questions on the second one?
If only the x is under the square root sign, then why is the 10 also to the second power in the final answer?
Yeah, so good question. It has to do with the order of operations. So we're finding a function that undoes the original in the reverse order. Okay, so in this case, in our original function, when we plug something in, we take the square root first and then add 10. Okay, so square root first and then add 10. We want to do that in the reverse order. So we want to subtract 10 and then square whatever that number is. So that's why it's in parentheses. We subtract 10, that's in parentheses, that's the whole thing. And then we square the whole thing. So that's why you have to be careful of your orders of operations. Good question. And you can rest assured, like if that was a multiple choice question, like this would be one of the wrong answers, right? Square it and subtract 10. That would be incorrect. But of course, teachers are mean, and that would be an incorrect multiple choice answer. All right, let's try another one. All right, let's say f of x is x to the 7th minus 6 over 9. And we want to find its inverse. All right, I'll do the green method first. Okay, but you don't have to do this. You could skip this totally if you wanted to and just look at it like this. But I think some of you might like that. So I'm going to write it as y equals x to the 7th minus 6 over 9. Switch the x's and y's. So I get x equals y to the 7th minus 6 over 9. And then I have to solve that for y. So the first thing I'll do is multiply both sides by 9. So I get 9x equals y to the 7th minus 6. Then I got to move the 6 over. So I get 9x plus 6 is equal to y to the 7th. And then I have to take the 7th root, or I could do the 1/7 power. That would be fine also. So I'll write it as a root, but you could also do to the 1/7 power. So the 7th root of 9x plus 6 is equal to y. And this is our inverse function. So that's the 7th root of 9x plus 6. Now to show you the little TV method here. Okay, looks like a TV, maybe. Although it doesn't look like your TVs because you guys never had an antenna TV. I'm really dating myself here. All right, so here's our function. If we plug something into here, follow the order of operations. The first thing we would do is do the 7th power. Then we subtract 6. And then we divide by 9. So we have to do the complete opposite of that in the reverse order. So the first thing, if we're going this way, first thing we do is undo that by multiplying by 9. So we take our number and multiply it by 9. Then we did this, we have to undo this. Instead of subtracting 6, we're going to take that number and add 6. And then working our way up, we did this, we did this. We now have to undo the 7th power. We do that by doing the 7th root. And again, there is our inverse function. All right, I'm going to have you guys try a couple. Before I do so, do you have any questions for me? As I looked on your work, I saw many people using the equation method, which is perfectly fine. I'm going to do that second then, just so you can check your work though, and just use the more kind of analytic TV method. I guess I'm thinking here. If I were to plug in a number, if I take the number 50, and I just made that up, if I plug it into this function, the first thing I would do is I would subtract 8 and then take that to the 1/3 power. Okay, so I'm going to subtract 8 and then I'm going to do the 1/3 power. So now to undo that, I'm going to take when I plug something in here, to undo the 1/3 power, I have to cube it. And then to undo the subtract 8, I have to add 8. That is our answer, x cubed plus 8. Now, of course, many of you that did the other method came up with that answer, and that's perfectly good way to do it. So I'll switch the x's and y's. So then I get x equals y minus 8 to the 1/3 power. And I'm going to solve this for x. Now, some of you got stuck here. How do I undo the 1/3 power? Well, I'm going to cube both sides. So I cube that and I cube that. Because what happens is, remember, for exponents, you multiply 1/3 times 3. Those two cancel out, and I'm left with y minus 8 on the right side is equal to x to the 3rd. And I just move the x or the 8 over, and we're done. Okay, same answer, same answer. All right, second problem. I'm in my green pen, so I'll do that method first. Switch the x's and y's, so I get x equals y to the 4th over 3. To solve that for y, I multiply both sides by 3. And then to get rid of the 4th power, I take the 4th root of both sides. Or some of you did both sides to the 1/4 power, which is perfectly fine. Okay, so you could have some of your answers look like this: 3x to the 1/4. And both of those mean the exact same thing. Okay, but you do need the parentheses here. Okay, and again, using the other method. Okay, if I plug something in here, first thing I would do is 4th power and then divide by 3. And divide by 3. So if I take my number to undo that, I multiply by 3. And then to undo the 4th power, I do the 4th root, or take it to the 1/4 power. And that again is our inverse. So I should write that up there. All right, last one here. So we have 6x to the 3rd. If I'm going to write my inverse, if I plug a number into here, the first thing I'm going to do is take that to the 3rd power. So to the inverse of that would be taking the cube root of x. And then instead of multiplying by 6, I would divide by 6. And that is our last answer. Cube root of x over 6. All right, any questions? All right, well then we are going to go back.
Question.
Yeah.
For the final one, if you also had the divided by 6 inside of the square root, would that be correct or not?
That would not be correct.
Okay.
Okay, it cannot be underneath the radical. Yeah, the order of operations are very important and kind of tricky when it comes to these inverses.
So on the last one, you can't do the to the power of like 1/3. That one doesn't work.
No, you could do that as well. So you could write this as x to the 1/3 divided by 6. That would be fine also. Yeah, I should have mentioned that. Thank you, Sam. This and this mean the same thing. All right. I'm going to go back to my notes. And now I'm going to give you a little bit different type of problem. And so in this kind of problem, we are going to convert to exponential form. So what we're going to convert is something that's in a logarithmic form, in a log form, and we want to write it in an exponential form. So for example, remember when I wrote that log at the beginning of the lesson? Let's write this: log base 5. So remember, that's a subscript and written smaller and below. So log base 5 of 2x is equal to 6x. Okay, that's an equation. I know it looks really ugly to you guys because you haven't seen logs before, but believe me, when we start getting into solving stuff, the solving is not all that bad. But being able to convert is a huge skill in being able to solve these. All right, here's what we need to do. If we want to change something that's in log form, I need to undo the log. I need to find the inverse of log base 5. And the inverse of that is taking 5 to the power of that. So for example, if this is an equation, what I can do is take 5 to this power and 5 to that power. So I'll write it out. So I'm doing 5 to the power of log base 5 of 2x is equal to 5 to the 6x. Okay, I'm just did like 5 to that power and 5 to that power. Now, the reason I would want to do that is because remember, logs and exponential functions are inverses. So they cancel each other out, just like multiplication and division, just like addition and subtraction. So what happens here is this 5 and log base 5 cancel out, and I get 2x is equal to 5 to the 6x. And that is our answer. It has been converted to exponential form. By the way, I didn't solve that for x. We'll get to that later. So we're not solving it. We're just converting it into an exponential form. All right, that's going to take some practice. So let's do another one here. All right, let's take log base 4x of x minus 1 is equal to 10x. All right, so we want to convert that. So I look at what the base is. The base is 4x. So that means I'm going to take 4x to this side and then 4x to the other side. So I'm going to do like this. Okay, 4x to the log base 4x of x minus 1 is equal to 4x. I really should have that guy in parentheses to the 10x. So whatever the base was, I took 4x to the power of both sides. And the reason we do that is because the 4x and the log base 4x cancel each other out. And so we're left with x minus 1 is equal to 4x to the 10x power. And that is then written in exponential form.
I have a question. Can you cancel the x's, or do the x's have to stay there?
You cannot cancel the x's, no. Because one, I assume you mean these x's? Like here?
Yeah.
Yeah, no, you can't because it's not a fraction. If it was a fraction, you could, but it's an exponent.
All right. Thank you.
Sure. All right, let's do one more. So let's say we have here log base x minus 2 of the 4x plus 1 is equal to 3. So I'll take x minus 2 to the power of both sides. So I do x minus 2 to the log base x minus 2 of the 4x plus 1 is equal to x minus 2 to the third. And the x minus 2 on the left side, the x minus 2 and log x minus 2 cancel. So we get 4x plus 1 is equal to x minus 2 to the third. So that process is for you people that like algorithms and how to follow that. For you visual people out there, here's another thing that students do just as kind of a visual that works. Is if you look at the problem we just did, if you're trying to convert it from log form into exponential form, this number stays. This thing moves over there, and this thing becomes your exponent. Okay, let me say that again. So 4x plus 1 stays. The x minus 2 moves over, and it was here. And then the 3 moves up, that was here. So like in the previous problem, this stays, this moves over, that moves up. So x minus 1 equals 4x to the 10x power. Or in the previous one, that stays, that moves over, that moves up. Or 2x equals 5 to the 6x power. So you can do that either way, but you do have to be able to convert back and forth. Like that's a huge skill that we're going to use moving forward. So we're going to practice a couple on a class kick, and then we'll go over those together. All right, let's take a look at these. And in the interest of time, I'm going to use the visual method But if you want me to go over, how to do that algebraically, I am more than happy to do so. So this is going to stay. This moves over. This moves up. And so we get x equals x plus 2 to the 3x plus 1. That's our first answer.
I have a quick question.
Yes.
What if there's like nothing after like the x plus 2? Like if there's like nothing there.
Nothing here? Oh,
Yeah.
good question. Impossible. It's
Oh.
impossible because log is a function and this is your input into the function. So there has to be something there. Okay, good question. All right, let's do the second one here. So this will stay, that will move over, that will move up. And so I get 5 equals x plus 2 to the 3/2 power. And we also had the question like, can you switch sides of the equal sign? Yes, you could write x plus 2 to the 3/2 power is equal to 5. That means the same thing, of course, and that's perfectly fine. Any questions on the first two? All right, the last one. Yeah, this one, I apologize. I didn't explain what that thing means. ln means natural log. I know the letters are not in the right order saying it that way, but it means natural log, and I'll explain why that means and what that means as we move along. But in terms of what we're doing now, ln means log base e. So I would write that as log base e of 3x minus 2 is equal to 1/2. Okay, e is a number. So it's roughly 2.7, just like pi is roughly 3.14. So if I write it in this way, I can use the same method. This will stay. E moves over. That moves up. And so my answer would be 3x minus 2 is equal to e to the 1/2 power.
So what would, like in problem 6, what would the first, like before the parentheses mean? Is that like in?
It's
Is it
an
one?
L. Actually, this is an L and not
Oh,
an I.
ln.
So ln, and what ln means is this. It means log base e. Okay, ln is the same thing as log base e. It's kind of like a shortcut, I guess, because it's used quite a bit in some real world applications that we'll do later on. All right, good questions today. Anything else here, guys?
Wait, what is it? Is it in or ln? What is it?
ln. It's not an I, it's an L.
Okay.
ln.